Anyway, so here's another one. Again, what do? Reactants, products. We have phosphorus and hydrogen. Okay, we have 4 phosphorus on the left. We have 1 phosphorus on the right. We have 2 hydrogens on the left. We have 3 hydrogens on the right. Okay, this is kind of weird. Why don't we balance the hydrogens first? I always like to balance hydrogens first on most cases if they're in the equation. Okay, what's the common multiple between 2 and 3? 6, right? 2 times 3 is 6. So I'm going to put 3 times 2. What times 3 equals 6? A 2. Okay, so that changes this 1 to a 2, 2 phosphorus now, and it changes this 3 to a 6. Okay, what times 2 equals 6? A 3. So I'll change this 2 to a 6. Okay, so, well, that didn't work out because the phosphorus still is not where we want it to be. What if we do this? Instead of using a whole number, I'm just going to make this a half. What does that do? What's a half times 4? That's 2. So 4 divided by 2 is 2. And it worked. And I know you're thinking, well, how can you take this molecule and divide it in half? Well, you've got to understand when we're talking chemical reactions, when we're talking chemical recipes, we're not dealing with just single molecules or single atoms. We're dealing with a lot of molecules and atoms. In fact, we're dealing with moles and moles and moles of atoms and molecules. Right, so we're not splitting the atoms when we put the fractions in there as the coefficients. Okay, let's try another one. Here we have the reactants and we have the products. Okay, we have, what is this? Au, that's gold, Au. And we have sulfur, capital S, and we have hydrogen. Okay, so on the left, we have 2 gold atoms, 2. We have 3 sulfurs, 3. And we have 2 hydrogens, 2. On the right, we have 2 hydrogens, 2. We have 1 sulfur, and we have 1 gold. Okay. Interesting. So this material right here, that's what happens to gold when it's dissolved in a solution, in a water solution with sulfur. So it looks to me like if you can take that solution and bubble hydrogen through it, hydrogen is a gas at room temperature, you can get the gold out. So this is a way to prospect for gold, or to get gold that's dissolved in a water solution. Okay, so where are we going to start? We could start with the hydrogens like I like to, but the hydrogens are already balanced. So I'm going to start, let's try starting with the sulfur, because we could start with the gold, but notice how gold is here by itself. So no matter what number we put in front of this gold on the product side, you're not going to change the number of anything else. So let's do the sulfur first. Okay, so there's 3 sulfur on the left on the reactants. There's only one on the right. So I'm going to put a 3 here. And that's going to change the hydrogen to 6, because 3 times 2 equals 6. And then this sulfur, instead of 1, it's a 3. Okay, so now notice that the number of hydrogens on the right is 6 now. The number on the left is 2. So what times 2 equals 6? 3. I'll put a 3 here. Okay, that makes that a 6. And the gold on the left is 2. The gold on the right is 1. So I'm going to put a 2 there. And that becomes a 2. So everything is balanced. 2 on the left, 2 on the right for the gold, 3 on the left, 3 on the right for the sulfur, 6 on the left, 6 on the right for the hydrogen. So what does this say? This says that in order to get 2 atoms of gold, using this chemical, using this recipe, you're going to need 1 formula unit of gold sulfide and 3 molecules of hydrogen gas. In the process, you will make 3 molecules of sulfur hydride and 2 atoms of gold. Okay. I'm going to keep going, but if you guys want to pop out and pop in, that's fine with me. But I've got 2 more. Let's see if we can do these. So again, first step, make your table. Reactants and products. List all the atoms. We got iron. We got, oops. Iron. We got chlorine and sodium and sulfur. Oops, I hope this is not a problem. Okay. On the left, we got 1 iron. We've got 3 chlorines. We got 2 sodiums. And we got 1 sulfur. On the right, we have 2 irons, 3 sulfurs, 1 sodium, and 1 chlorine. Okay, what do we balance first? Let me see. How about the chlorine? There's an odd even there. So there's 3 chlorine. Is that right? No. One iron, 1 chlorine. I see 2 irons on the right, 1 chlorine. Okay, that's right. So 3 to 1, 3 to 1. Wow, what should we do first? See, at this point, you have to make a decision. Now, sometimes you make the wrong decision and you just have to back out. But so I'm gonna stick with the chlorine. So I'm gonna put a 3 here. So now this 1 becomes a 3. Okay, and because there's 3 chlorine, and the sodium, this 1 also becomes a 3. So the chlorine is balanced, the sodium is not. There's 2 sodium on the left, there's 3 sodium on the right. So that didn't work out too well. What if I make, odd even, like 3 and 2? So the common multiple is 6. So I'm going to erase that. Okay, so I'm going to put a 6 here. Let's see if that works. So instead of 3, that's a 6. Instead of 3, that's a 6. And then I'm going to put a 3 here. 3 times 2 equals 6, so that 2 becomes a 6, and that sulfur is now a 3. Okay, that worked out really well because notice how the sulfur has 3 on the left and 3 on the right. Okay, what about the chlorine? How about if I put a 2 here? 2 times 3 is 6, so this becomes a 6. And that 1 becomes a 2, and we're done. How's that? Okay. Reactant, product. We got aluminum. We got oxygen. Oops. We got hydrogen. And we got chlorine. Okay. On the left, we got 1 aluminum. On the right, we got 1 aluminum. On the left, we've got, notice how this OH group, this hydroxide, is inside parentheses. So everything in that inside the parentheses are multiplied by this number on the bottom right of the right-hand parentheses. So we got 3 oxygens. Oops. 3 oxygens. 3. There's 3 hydrogens, but there's also a hydrogen right here with the hydrochloric acid. So that's 4 hydrogens. And then we got 1 chlorine. Okay, oxygen's on the right. We've got 1 oxygen in that water molecule. Hydrogens, we got 2 in the water molecule. And then chlorines, we got 3 in the aluminum chloride formula unit. Okay, what do we, I always like to do hydrogen first for some reason, although the fact that the hydrogen is spread out here, it makes it more difficult. But anyway, so we need 4 on the right. So I'm going to put a 2 here, and that makes that 2 hydrogens into 4 hydrogens. And that makes that 1 oxygen into 2 oxygens. Okay, well, that doesn't do much good for the oxygens. Well, let's keep going. Let's do the chlorine. There's 3 on the left. On the right, there's only 1 on the left. So why don't I put a 3 here? And that makes that chlorine a 3. But instead of having 4 hydrogens, now I have 3 from the aluminum hydroxide, 3 plus 3 in the hydrochloric acid. So that makes that 4 a 6. A 6. Okay, that kind of messed things up. So I have to look at that water. 3 and 2, 3 and 2. That's 6. Oh, how am I going to get out of this one? How about if I put a 3 over on this water instead of a 2? Why don't we try that? Okay, I'm going to get rid of that 2. And I'm going to put a 3 there. 3 times 2 is 6, so this 4 for the hydrogen now becomes a 6. 3 times 1, the oxygens. Instead of 2 oxygens, now we have 3 oxygens. Did that do it? Yeah, that worked. That worked. It's balanced. 1 and 1 for the aluminum, 3 and 3 for the oxygen, 6 and 6 for the hydrogen, 3 and 3 for the chlorine. Okay, now I know that this video kind of went a little long, but you can see that, I hope you can see there's a little bit of math involved, but most of the math, all of the math really, is just adding, subtracting, multiplying. It's really not so much the difficulty of the math. It's the looking at the recipe and trying to figure out the right ratios of different atoms to make different atoms and different molecules to make things balance. Okay, so I'm going to end it here. Take care.